Azure DIY Season 2, Episode 2. We've got a few minutes before a bunch of people join. Usually most people are about three or 4 minutes late. My name's Peter Cole from Microsoft, App Dev Specialist based in Sydney. I'm part of Cherie's team, and it's our team that's been orchestrating the Azure DIY stuff. So remember that this session will be recorded and will end up on YouTube and LinkedIn. There's a Q&A, question and answers down the bottom right of your screen. We'll be answering some of those during the session. And at the end, there'll be 15 minutes where we'll pick the best questions for Atul, who's the presenter today, to go through them. So they will probably pick the hardest ones for him. So this session is going to be on Azure Messaging Services, when to use what. I've already actually seen Atul's presentation. It's amazing. There's a lot of demos, a lot of very code-heavy demos, which I think a lot of you guys will really enjoy. Atul's from Contino as well, a really well-known partner, especially in Australia. So as we go forward, I've got a few kind of questions just to build a little bit of time for the first 5 minutes or so. Feel free to put what you think the answers are in the bottom right of the screen. We're starting off with a fairly easy one. Event Grid and Event Hub are both the same resource. The difference is only in their name. True or false? And this actually came up in one of my customers once, but it should be pretty simple. Are there any answers in the Q&A, guys?
We are waiting for the answers to come through.
So I got a few other ones.
Not yet. Yeah. Put in your answers in the Q&A section.
My next ones are going to be tougher, so I might skip through this one quickly. The answer is false. They're very different applications on Azure. The Event Hub is for huge data ingestions. Usually if you're tracking people in your websites or for marketing. Event Grid is kind of between applications and so your event routing software. Next question. As of September 2020, approximately how many connectors does Logic Apps have? 200, 300, 400, or 500? Now, this is interesting because Logic Apps have been around for a while now, and it's very similar to Power Automate. In fact, they're getting built around the same time. For anyone that doesn't know, connectors are maintained by Microsoft and third parties. You connect to software such as SAP, Salesforce, Dynamics 365, and they're really good for workflow orchestrations, and you can also do transforms in them. So 200, 300, 400, or 500. So I help you guys out a little bit. Let's remove the top two. So you're down to 400 and 500. So it's actually crazy seeing it built from like a Microsoft standpoint, just the rate of change in Logic Apps and the amount of every day there seems to be more connectors. In this case,
we have got an answer. Wait. We have got an answer from Martin. 400. 400
is correct. So over 400 connectors in Logic Apps. And that's the same as Power Automate because effectively they use the same connectors. Awesome. What year did Azure IoT Hub reach general availability? 2012, 14, 16, 18. Now, IoT is really a really interesting topic because it's very big and it seems to be like flavor of the month every 2 months or so for the last 10 years. So it is interesting to think when Microsoft developed IoT Hub and made it general availability, because it feels like it's been there forever. Do we have any answers so far?
Not yet, waiting. Just give us one more, like 30 seconds. People are popping in their answers mostly. Yeah,
and this is the final question.
So you've got an answer, 2016.
Yep. Oh, you are actually correct. That is great. Yeah, 2016 is when it became general availability. Awesome. And finally, just before we hand off to our presenter, this is what we have coming up. Last week, you saw Microsoft's journey in embracing modern DevOps. This week is Azure Messaging Services, when to use what. A lot of demos. It's going to be a fantastic session. Next week, we have the Fast Track team coming in and talking from developer to architect, geo-distributed solutions using Azure PaaS, which is going to be a fantastic session. It's all about DR, HA, and scaling your PaaS services around the world. So it's really great for those enterprise customers or even startups or other companies that really want to scale around. And if you haven't already, Please join our LinkedIn community. We're trying to grow it. We're going to be pushing reminders out about these sessions. We're going to be posting these videos. This session's recorded for anyone that just joined. They will be popping up on YouTube, and we'll be linking it on LinkedIn as well. So please join our LinkedIn community. Great way for us to get information out there. Awesome. And I'll hand off to Atul now. Everything good, Sheree?
Yep, Atul is live now.
Sorry, just give me a second. Thank you, Peter, and good afternoon, everyone. My name is Atul Kriplani, and I'm a technical principal at Contino. And in particular, I focus on app dev on Azure platform. I've been consulting now for over 10 years, and more recently, I've been working on Azure governance, building cloud native controls to ensure the platform is fully secured and compliant. But this topic is not about security. Well, regardless of what type of application you build, whether it's for an online shopping system or a virtual assistant, a gaming application, or building compliance as code, most modern applications are distributed in nature, and reliance on decoupling the application component through event-driven architecture is required to ensure they are independently scalable. And at the same time, it is important that these messages are securely and reliably delivered. So for today's session, we will look at different messaging services that are offered by Microsoft Azure. For each messaging service, we will walk through the primary features and will help give you an understanding of what to use for your own applications and enterprise scenarios. There is some overlap in functionality between some of these messaging services, but each of these services are targeted towards specific messaging use case. In order for us to determine, I generally look at two parameters. The first one is what type of message is your application dealing with? The next one is what are your consumers going to do with those messages? Along the way, I will demo you, some kind of how these services can be used either individually or as a combination. So that's today's agenda. Before we begin, I would like to tell you about Contino and what we do. We are obviously a Microsoft Gold partner, and we are a technology consulting company with a strong pedigree in digital transformation and cloud enablement, with some of the world's most recognized companies and brands. As you can see on the slide, we help our customers with measurable transformation through adoption of enterprise DevOps, cloud native computing, and data platform. And currently, Contino employs over 350 people, and we are growing at an exponential rate with 5 global offices in the US, UK, and Australia, and we are still growing. What we do, we basically advise, we build, and we upskill. So we basically focus relentlessly on helping our customers deliver superior experiences to their customers. We fundamentally transform our customers' business across people, process, and technology, and we deliver on projects while upskilling our customers' teams. I would be happy to try and answer some of your questions towards the end of the presentation. We do have a lot to cover, so let's get started. Let me start by giving you an overview of each of the service. I'll first start with Storage Queue. This is one of the most highly used, but this is the first messaging service that was built on the Azure platform. This is part of the Azure storage offering and allows us to store a lot of messages in the same queue. And when I say a lot, I mean you can store messages up to 500 terabyte in one queue. Although this gives us the ability to store large amounts of data in queues, I would recommend keeping the message as light as possible. The next one we will look at is Service Bus. This is quite similar to Storage Queue with more advanced capabilities of a message broker, like message ordering, duplicate detection, sessions, and so on. Then we have Event Grid. This is used to subscribe to events and push these events to anywhere in near real time. Event Hub is used to ingest large stream of data. It gives us the buffer to store these messages and process at our own pace. IoT Hub is another flavor of Event Hub, but is a very specific service used for connecting to IoT devices that allows you to send telemetry data from device to hub, basically bi-directional, allowing you to send messages from device to cloud and cloud to device. Therefore, allows you to manage these devices as well. Devices like your car, some temperature sensors, your energy meter, and so on. The next one we look at will be Notification Hub. This allows you to push notification to many platform notification services in many protocols, thereby allowing you to send messages to multiple devices on multiple platforms like Windows, iOS, Android, Amazon Kindle, and so on. SignalR service. This is a managed version of ASP.NET Core SignalR, which allows you to push real-time messages to connected clients. Any applications that allow you to collaborate, chat, or any other kind of collaboration application, you would be using SignalR for that. In the beginning, I mentioned I would look into two key parameters, right? So the first one was what type of message is your system going to emit? So before we go into looking into the key differences, what I want to talk about here is there are two things that I like to distribute our messages into. One is an intent and the other is a fact. And I like to call that event. So with messages, they are basically raw data produced by a service and that needs to be consumed and stored. So there is like a command and you need to respond to that message to do something. The message should contain the data that you want to process, and then the contract exists between the publisher and the consumer. So the publisher with an expectation on how it should be consumed, and the consumer with an expectation on how it should be structured, the contract. The next set is basically events, which are facts. So they are discrete facts. Something happened, the door opened. Sorry, just keep that. Just give me a second. Yeah. So something happened and you've basically got an event, the door is open, and that's like a discrete event. And then the other one, which is stream of data. So that's like contextual data. So you have telemetry data coming from your meter, and which is giving you 15-minute incremental reading across your meter. So they are all interconnected stream of data. They are generally lightweight in nature, and they have no expectations on how it should be consumed. So the consumer decides what they need to do with this message. So if I have to use storage queues, service bus, SignalR, IoT hub, I would ensure that they are basically of the type message on the left. And then when event grade, event hub, or SignalR, if they are basically facts or stream of data. So let's start by looking into some of the key differences. I'll start with storage queue. Storage queue basically is, as I said, one of the oldest service. It gives you a point-to-point messaging system. So you basically have one publisher. You could have multiple publishers to the queue, but then you generally have one and only one consumer of that message. You can then do something like competing consumers where you can increase the throughput of the queue, but that's basically only one consumer is still processing a given message. So you can't have multiple consumers receiving the same message. The next one is basically service bus, but some of the limitation on storage queue is basically you can only have up to 2,000 messages per second on a given queue and 20,000 in total on a storage account. So if you need more than that, then definitely storage queue is not your option. But if you need more than 80 terabyte of messages that you want to process, then storage queue might be an option. Service bus comes in two flavors, right? We have service bus queues and we have service bus topics. Queue is quite similar to storage, where you have point-to-point schematics, but with topic, it allows you to have multiple subscribers to a given message. They both basically require byte array, binary data, and also allows you to send some metadata, which is basically system properties like correlation between messages so that you can do transactions. And then the other one is your user properties, which is like a key value property bag, which allows you to do some filtering. So with service bus topic, it gives you an additional feature that you can filter, and you can do routing on your queue, and you can have multiple subscribers, each receiving a given message that they want, or the same message as well. So that's basically service bus queue. And I think let's get into the demo, the first demo. Before I begin, I want to show you what I'm going to show today. It's the first demo is going to be point-to-point messaging, where you send a message to the queue. The service bus then forwards it to the subscriber. Subscriber lets service bus know I've completed processing. The next one is where we have competing consumers. So you still have just one subscriber, but multiple instances running of that subscriber. So the first message comes in, service bus forwards it to one instance of that subscriber. And then basically another message comes in, but this time it goes to the subscriber instance 2, which is basically a round robin pattern that service bus dictates by default. So if the third message comes in, you expect that to go back to the first instance of subscriber. So that's one of the other demos that I'm going to show. And then we have multiple subscriptions where you have one message coming to the service bus and you have multiple subscribers to the topic. and you're going to emit both are going to receive a copy of that message. So similarly, if we push another message, then you're going to have multiple copies. So let's start by looking at the code for that. As you can see here, I've got a solution which is written in .NET Core. These are 3 console applications where I have the publisher, the subscriber, and multiple subscriber as a separate project.
Atul, do you mind zooming in a bit?
Sure. Can you see that better?
Yes, that's better.
Yeah, cool. Thanks, Sri. So with this one, what I'm going to show here is that I have this publisher where I'm going to basically connect to a particular topic, which I've already created. I've created a service bus, and I'll show you that in the portal as well. So I've created a service bus with, let me just bring that up, and I will show you that. So if I go back to my resource groups, service bus demo, I've already created.
Here as well, if you can zoom in the screen.
Sure. Does that look better?
Yeah.
Yeah, so I've got a service bus namespace over here. So namespace basically allows you any collision that you might have outside of that. So you might have collisions in your messages internally, but from outside other namespaces, you will not have a collision to your message. So this basically, as you can see, I have 2 different entities. One is a queue and one is a topic. For today's demo, I'm going to use topics. So when you look at a topic, you will basically see that I have a topic created called DIY-demo.topic. This is the topic that I'm connecting to in my code. So I've got the connection string here. You could use RBAC Azure AD to authenticate to the client. The client can use different mechanisms to authenticate. So we have created an instance of the topic client, and basically we are just creating a JSON body here, and we are converting that into byte array, setting the metadata, which is the system properties, correlation ID, and the content type being application JSON. And then we have a user property bag, which basically is going to add different properties that we want to allow our subscribers to be able to filter on and do routing. So pretty much sends a message to service bus, and then I wait for a key to enter, and I can send more messages. Until I press exit, this application is going to keep running. So let's start that application. Demo code. What I'll do is I'll also start my subscribers. Sorry. So I'm going to show the code for the subscriber as well, but what I'm going to do here is I'm going to run the subscriber and see whether I do receive a message. At this stage, it seems like there is some issue with the code that I would have entered. So if I look back into my portal, let's troubleshoot. So that's DIY demo topic. I had said, there you go. I had set the default project to be the subscriber, and I'm expecting the publisher to run, but obviously the publisher is not my default project. So I'm going to set that as my startup project. Apologies. And as you can see here, I've sent one message now, and I have my subscriber running as well, which has received the message. So this is me sending one message to the subscriber and the subscriber receiving. I'm now going to show you competing consumers. So for that, I'm going to spin up another instance of my subscriber. Let me do that. Let me put it in a way where you can see what's happening. And I send another message here, right? Now you see I send one message, it has skipped a message before. It's here. I didn't have that scroll properly. But now what you can see here is message 5 comes in the window below, message 6 goes up, message 7 comes down, 8 goes up. That's like a round robin that by default it applies. So only one instance of the consumer can get the message. So I'm going to close this now. What I'm going to show you quickly is the subscriber code as well. So the subscriber here, basically I create I pretty much listen to the same topic, and I have a subscription, which is DIY demo.notify. And I'll show you that quickly in our portal. that for that particular subscription, for that particular topic, I have subscriptions. I've got 2 subscriptions at the moment. So I've got DIY demo, and you see I've sent 4 messages. The other subscriber is still waiting to process these 4 messages because I haven't kicked off that as yet. So if you go back to our code, what you will see is I've got this notify queue that has been listening to events, and hence notify queue is 0, but the process queue, subscription is still yet to process those 4 messages. So what I'm going to do is I'm going to now stop my, I'm now going to go and run my multiple subscriber demo, and I'll show that code as well shortly. Let me just bring up my console app. This is my publisher, and I'm going to run this app now. And what you'll see that I've got the messages that I hadn't processed before over here, which belong to me. Now, what you would see is that I didn't receive as many messages for the second subscriber as I would have expected. And the reason is because for this particular subscriber, we've basically done routing. And what we've set up a routing filter here to say that I only care about messages which are from category A and B. So in my code, if you go back to the publisher, I basically had a category that I'm passing here, and I'm generating that randomly from this particular array, which I have A, B, and C. And some of the messages were C, so obviously they haven't been delivered to that subscriber. So now, if we go back to our console app, and if I start pushing messages from here, you will see that's another C. Only one received the message, and that's an A. So both received it. That's another A, so both received it. So you can see your count 11, and I've kept the color different for each subscriber, so you can differentiate the message being processed. And anything that's got C will only be processed by one of the subscribers. So that's basically the demo for Service Bus. I'll quickly show you the code, what we had inside the multiple subscriptions. I basically had the same topic, but I had 2 subscriptions here, the process and the notify. And I have created a subscription client for each. And then I've got a message delegate here, which basically handles my message. So we are not pulling messages, but we basically waiting for a message to arrive, and then the delegate gets invoked. The delegate method gets invoked when the message is ready. And this is where we basically set the foreground color before we print out the message. So if it's 1 queue, then I'm kind of saying keep the color green, otherwise keep the color yellow. And that's us notifying Service Bus that we've successfully completed processing this message. One good thing is the default behavior of Service Bus is peak lock. With peak lock, you basically are guaranteed to process this message at least once, because if the subscriber fails at the time of processing, and if the message is locked, then the message remains in the queue. And after a certain period of time, it'll then be available for another subscriber to read it. So whenever the subscriber comes back online, that message is guaranteed to be delivered again. So that's one of the good features as well. So let's now go back to our presentation deck. So next, we are going to look at the other services that I spoke about before, which is Event Grid, Event Hub, and IoT Hub. And I would like to tell you some of the key differences here, right? So with Event Grid, it's highly available, highly scalable, cheap service. It comes in 2 different messaging queuing system that you have. One is like a system event, system topic, and one is like a custom topic. System topic is generally where you would want to react to something that happens within your Azure subscription. So for example, if a blob was created and you want to trigger your Azure data pipeline, data factory pipeline, then that might be the right choice for you. So you would register to the event and then forward that message to a given subscriber. It allows you to pretty much send this message to any subscriber because it listens to a webhook as well. So it's more suited to serverless architecture, and it's quite cheap. It pretty much costs you 60 cents for a million operations that you do. For Event Hub, it is if you need message retention for a long time, it's a great choice as well. It captures all your streaming data, gives you the buffer that you need to process the messages at your own pace. Again, the message type is like a binary content with metadata and user-defined property bag. Max size is 256K. and you have the ability to replay events as well. So this is one of the cool features where, if you haven't been able to process it by one subscriber, and then, the other one wants to see it, you could replay that set of events to ensure that you processed it as expected. And then the other one is IoT Hub, which is quite, dedicated more towards when you're dealing with IoT devices, stream of data coming from your IoT devices. One good thing that I like about IoT Hub is the fact that it gives you this digital twin of the device. So what that means is that when you are when you're communicating with the device, you're not necessarily connecting straight away to the device, you're talking to the digital twin. So if the device is not online at that point in time for whatever reason, the message is still delivered to the hub and is kind of updated on the digital twin. And whenever that connectivity between the digital twin and the actual device is managed by IoT Hub. So that's pretty cool. So you are also able to manage the devices, not just kind of get and send messages. That gives you the ability to manage the device as well. And so the other one I want to talk about is SignalR. SignalR is a pretty cool service. It's sends real-time messages to connected clients. Could be any type of client. Could be a browser. Could be a mobile device. Situations where you would use this is when you want to do some dashboarding, some monitoring. Some kind of your back office system that needs to see live data of your drivers on the road, and you want to see how fast they are going. Where are they exactly? Is the delivery on track? Do you need to route your driver somewhere else? That's another good use case where we've used SignalR before. And then real-time applications, delivery status tracking, as I said, collaborating apps for your chat and all those other different types of applications. So let's go into the demo. Before we go into this demo, I want to quickly show you what I'm going to demo today. It's, as I said, this is my demo for combination of services. Basically got a Raspberry Pi simulator on Azure, which I'm going to send messages to my IoT Hub, which I've already created, and I'll show you that in Portal. And then that message basically gets into the backend endpoint, which is nothing but the Event Hub endpoint. That message then gets forwarded to a serverless application Azure function that I've written in Python, and that basically goes and stores the device state into this table storage. I then have a static website that I've hosted in Azure Storage, which basically connects to the SignalR service, and the SignalR service basically goes to a function app, which is basically where it's receiving the data coming from IoT Hub directly. So all the messages coming to the IoT Hub are being forwarded to it. The reason I have this connectivity here is because I'm getting the initial state of the device. So other than that, the messages are directly flowing between the two serverless apps. So let's have a look at the demo quickly, and then I'll show you the code a little bit as well. So that's my Raspberry Pi simulator, and I've got a static website. It's a simple dashboard with a chart embedded over here. It's like a C3 plus D3 chart. And what I'm going to do for today's demo is I'm going to send messages from this device. Every time the message goes in, you will see that it's, and let me refresh this first quickly. When I send the message, you'll see that the light's blinking as well, which basically, and you can see the console as well, where the messages are going to the hub. So when the message starts feeding in, at some stage, my device will basically have that connectivity and get the message coming through from the hub. And you can now see that this is in real time, giving you the data. So you can see what the temperature here looks like and pretty much what you can see here. So every time it's beeping, you see that there is a movement coming in. And just to show you that I'm not lying here, I'll show you what the console looks like. So this is basically a WebSocket that we've created with the SignalR service, which is a function app. And I'll show you the network traffic here. Just give me 1 second. So what happens is when the browser is connecting to SignalR, it doesn't negotiate, and that at the time of negotiate, it basically returns you the URL that you need to where the data will be coming from. This is like the function app that I've hosted. So it negotiates with that, and then any future event that you see, it's coming via this hub. So SignalR keeps sending the message. Whenever the message arrives, it's forwarding the message to the connected clients. So that's what we see here in our demo. So let me show you the code, how this works. If I go to my resource groups, I have one where I've set up my email. So this is the one. So I've set up a few things here, right? I've got basically, how do I make this better? Is that still okay? Still visible? Shri?
Yes, that's visible.
Yeah. So I've got two of my function apps here. One basically which is ingesting data from my Event Hub endpoint, and then the other one which is basically processing that message, storing it to the table storage, but at the same time forwarding that message to my SignalR service, and then the SignalR service forwarding it back to creating that bi-directional communication with the connected client. I have an IoT Hub here, and that's the connection string that I'm using on my simulator. So I'll show that code as well in a minute. And then I have my storage account where I'm storing my my device state. So if you go here, you'll see that inside the table storage, I'm pretty much storing my device state in this table. So going back here, I also have my SignalR service, and this is the endpoint that I have registered with my function app, and I'll show you in the code very shortly. So I've got three applications here. The first one, which is my static website, which is basically connecting to my hub. So over here, I basically have a SignalR, and it's quite straightforward. You just need to create your hub connection. You then basically point to your base API URL, which is my function app that I'm registering to. So if you have a look at that one, it's basically that function app that I just showed you before. And whenever the message arrives, it's basically invoking my function, which is new message. Basically goes and updates the chart in the display item. So it kind of goes and updates the chart. So all in one single file. It's a Vue.js static one single page that I've done quickly to demo this thing. So that's how our client looks. So whenever the message arrives, it's going to go and update the chart. And then the other one we have here is our so this is my Python function app, which basically is connecting to the, if you look at this one, it's basically connecting to my IoT Hub, which is using the backend endpoint. So if I go into the portal, I'll quickly show you that this is my IoT Hub here. And I have this built-in endpoints. This is basically nothing but your Event Hub style endpoint. So this is the endpoint that I'm using for connecting to my. So when an event arrives on the hub, I basically take that message, decode the message, go and update the device state in the table storage, pretty much that. And then at the same time, I notify the SignalR update. So I'm notifying SignalR over here. So as you can see here in this function, so if I go here, you will see that I'm basically invoking the SignalR URL. The SignalR URL is nothing but the same function app where I have my SignalR service connected. So the SignalR URL is nothing but, and I'll show you that quickly. So that's basically calling my backend function app. Yeah. Sorry, that's it in my settings. SignalR URL. So this is basically that function app that's talking to SignalR service. So I'll quickly show you that function, which is the one that's gluing things together as well. That's here. That's basically a .NET Core function app. What this does is it has a negotiate endpoint where it establishes the connection with the SignalR. So I'm using the SignalR binding here, and I'm creating a hub named DIY demo, and I'm binding that to my hub. So when the client sends that negotiate request, it basically creates that SignalR connection. Now this is the WebSocket, this is the bi-direction. So if you go back into looking our UI, as I've shown you in the console, so this is that negotiate endpoint to the SignalR that I'm sending, which is basically giving me the which is basically giving me that function app in the end, right? And if you look at it over here in the response, I'm basically connecting to my SignalR URL, and that uses basically over here uses WebSocket, right? So that's the negotiation endpoint, and then whenever the message arrives, we are invoking get device state. So if you look at that IoT Hub function, which is here, that's basically sending the invoking that get device state, right, when it's notifying the SignalR. So that code is, Yeah, so it's basically invoking that endpoint at this stage. Oh yeah. And that's basically it, right? So this is the main send signal out message. When the message arrives, we basically add the message and we forward the message. That's pretty much it. So the next demo I'm going to show you is on event grid. And for that, what I'm going to show you today is I've created a logic app here. As you can see, this logic app basically is listening to, I'll show you the code quickly. This is basically registering to an event grid event. This is saying when an event arrives, and this is basically a system event, so I don't need to create a topic for it because that already exists. What I'm doing here is I'm connecting to my storage account, and I'm saying whenever a blob is created, and I'm putting some filtering here. So I'm saying I only care about the demo container, so don't bother if it's any other container within that storage account. So whenever the message arrives on the demo container, I'm basically going to trigger my function app. So let's have a look at this one. So if I go back here, you will see that I had my last event arrive at 10:35, and this is pretty much near real time, and I'll show you that. So I'm just going to open another tab here. Yes, stay signed in. And if I go to that storage account here, you will see I have already created a container called demo. And if I go and upload a file here now, what we will see is that that message should trigger my logic app function app. Let me just take that and upload it. So now if you go back to this one, and if I refresh this over here, you will see that that's already triggered. So you will already be able to see that that event got processed pretty much near real time. You can look at the message body that came in, and that was the blob that I actually forwarded, right? So you can see that. So in the next demo, I'm going to show you a custom event grid event, which we are going to forward. So for that, I have created an event grid topic. So this is a custom event. As you can see, there are no subscriptions to this custom topic at this stage. So I'll go ahead and create an event subscription. For that, what I'm going to do is I'm going to basically, I have another, let me go back here. I have created another logic app. And in this logic app, I'll show you what I've done. I'm basically saying because I want to invoke this function app, I'm basically going to just trigger this function app. It's a HTTP request. When that arrives, I'm basically going to go and publish an event to that particular event grid, right? And that message, I'm basically just sending a JSON data. I'm just sending some message, custom topic message going out, and that's pretty much it, right? So I've already connected to that particular event grid topic in my case. But when you create one of these events, you will be able to set which particular event grid topic are you connecting to. So I'm going to basically trigger this. This will go and publish an event into my topic. This is a custom event. And then I'm going to go and create another logic app now. So I'll show you this in a second. But before that, what I'm going to do is I'm going to go to my storage account and I'm going to go and create a queue for us. So I'll go to the queue and I'll add a demo queue. And as you can see in this queue, we currently don't have any messages. So what I'm now going to do is I'm going to register an event subscription for that topic. We'll call it DIY demo queue. So this subscription basically will invoke an endpoint, which is a storage queue. So I'll select that endpoint. I'll select my storage account, which is this one, I believe. I'll select my demo queue that I just created, and I'll confirm that selection. You can use manage identity and all the authentication options that you want. So now if I go here and if I go back to my logic app, so if I go to that logic app for the topic, and I'll go and trigger a message over here. So I'm going to run this thing. This is basically going to send a message to the event grid topic, and the topic is going to forward the message to the subscriber. So if we go and refresh our queue now, you'll see that the message has arrived. So this is one subscription to that message. I'll quickly now show you how we can have multiple subscriptions as well. So if I go back to my topic here, and that can be message going anywhere outside of Azure if you want. So for that, I'm going to just go and create a logic app. We'll call it logic app urban DIY FM2 Southeast, review and create. And that's validating. Come on. And I can create that. There you go. So the deployment is in progress. And what I'm then going to do is, hopefully this should come up quickly. Go to resource. We're now in our logic app. And I'm going to go and basically when a HTTP request is received. And I'll just save this because I need an endpoint. This is like a webhook, right? So I'm just going to save this. I'm going to get my endpoint. So this is what should get triggered. So I'll go back to the topic. Sorry, I'll go back to the topic. And I'm going to add another subscription to my topic. That's my logic app, sorry. I'm going to add another event subscription here. I'm going to say this is my DIY demo webhook. And you can add a lot of filtering over here as well. So you can look into it and you can add your own filtering. You can add some additional filters on different options that you can go through. I'm going to say this is basically a webhook. I'm going to select the endpoint. I'm going to give it the endpoint of my logic app. I'm going to confirm that selection, create it. Oops. Sorry, my bad. Great. So now what we do is we go back to our logic app, which is the one we had our topic. So we send another message from here. And this time, oh no, not this one, sorry. So we go to our, this was the one, right? Yeah. We run this trigger. So what we will now see is inside our storage account, the first one, we should see a new message arrive in our queue. So we'll see one message arrives over here. And what we'll also see is that our logic app, which we just created, received a trigger as well. And if you look at that, that's basically the message that that's come through. So as you can see, we can have multiple consumers and you can have your consumer pretty much anywhere in this instance. So let's continue with the next part of our demo of our presentation here.
Hey, I'll just jump in between. I'm pretty sure there's like so much of demos going on, and it can feel like a lot overwhelming just to consume so much. We know Atul is amazing, and he has prepped so much. But have a good news there. So post this session, he's going to share his GitHub link with you guys, which will have step-by-step instructions on each of this demo that he has done, such that you guys can do the POC on your time. And also feel free to reach out to us. We at Microsoft are here to help you guys with your projects and also Continue team as well. Over to you. Thank you very much.
Thanks, Sri. Thank you very much. All right, so the next topic, Notification Hub. This is pretty cool. I basically have been writing some code to build my own apps, but one of the key challenges I've always had is like if I'm building for my customer audience, whether it is Android or iOS, I need to deal with a lot of other platform-specific protocol or platform-specific SDK and work on that language. So Notification Hub basically gives us the ability to push notification across multiple platform devices with few lines of code. And pretty much if you go through the docs on MS, if you follow those steps, then you can integrate your apps with push notifications coming from Notification Hub, very few lines of code. And I'll show you how I've done that today. Integrates with your Azure mobile apps as well. So if you are using Azure mobile apps today, you can integrate that seamlessly with Notification Hub as well. It's pretty much you build your backend using .NET, PHP, Java, Node, any language, right? And you should be able to use Notification Hub quite easily. Also allows you to target when you're sending notifications to a certain set of users. So that happens using tags within that. So when you're sending a message from your backend, you can basically tag your user. So at the time of the user registration, you are able to tag that user so that when you want to target a particular notification going out to a subset of users, you're quite easily able to do that. Also has a built-in templating support, so allows you to do localization quite seamlessly as well. So let's go ahead and look at that demo. What I've done here is I've got an Android Studio project. I've created my small Hello World app for Android. And pretty much what I want to show you here is that majority of the code that I've got here, other than the 2 lines that I had from the start when I created my project, everything else I've pulled pretty much from MS Docs as per the documentation. What it does over here is in the main activity when it's loading, it registers to the notification hub. So I've configured my notification hub, and I'll show you that in the portal shortly. And then some event handlers. So basically, on start, I go and register my device, and once the device is registered, I've gone to Google's Firebase Cloud Management, and I've gone and registered my project there. I've been able to download a settings file, which I've then gone and updated over here in my build section. So I've got this Google Play Services, which I've gone to Firebase Cloud Management project, and I've downloaded that. And that's pretty much it. So I've registered my app there, and it's given me some of the keys, right, that I can use on my device. The next thing is a Firebase service, which again, I've pulled pretty much from MS Docs. What this does is whenever a message arrives from Firebase, so this is connecting to the cloud messaging service from Firebase. When the message arrives, I basically then go and notify that on my main activity from here. So that's pretty much all from MS Docs. This is my notification settings, which is connecting to my notification hub. And I've got a shared key here, which is just for listening purposes. So it's pretty specific. And then I basically have my registration. So this is where I go when I start up my application, it goes and registers with that event hub connection string that we have so that it can communicate back. So that's basically all from MS Docs. So I'm going to go and run this application here. And I'm also going to pull up my my notification hub that I can basically send message from. You could be doing this using any other backend, as I said, in all different languages that you could do, right? So if I go here to resource group, I've got my notification hub. Again, I've created a namespace. This basically allows you to have multiple hubs that you want to create. So in this one namespace, I've created one hub. And as you can see, I have now one app device registered. So if we go here, you can see this has basically run my application and it's registered this with the device. What I'm now going to do is I'm going to send a test notification from my notification hub. And I'm going to target my device, which is Android. I'm going to say, hopefully this works. Hello from AzureDIY. I'm going to send that message. And as you can see, we have received the message already, right? So that's pretty much it for Notification Hub as well. All right. So key takeaways for today, I would like to share. Basically, Event Hub is what you would use when you want to analyze any contextual data. So any kind of message that you're receiving which are interconnected, you would be using Event Hub for that purpose. You would use IoT Hub when you want to interact and manage devices, so device-specific use cases. Notification Hub when you want to send notifications to multiple devices on over multiple protocols. So those three, in my opinion, are quite straightforward. In fact, even Event Grid is more when you're dealing with some kind of discrete data where it's just a fact, your application needs to know about something and that's about it. The publisher of the message doesn't really care how it's going to be consumed. So that's the kind of nature for that. And then you have storage queues and service bus, IoT Hub, Signaler. When you have any message coming with an intent, that's the service that you would probably be targeting for that. So that's pretty much it. I think I've completed my session 10 minutes ahead of time. I think I've gone too fast, but I was just a bit nervous. We had too much to cover, and hopefully I'm now able to answer any questions if there are any outstanding.
Yeah, there are a lot outstanding. So let's go through the questions. So Give me a second. I'm just picking up one by one. We have answered a few of them. Okay, can we replace the Signal R with HTTP2?
Now that works with HTTP 1.0 at the moment, right? So that's pretty much what you have. I don't know when the timing looks like for HTTP 2, but I think it only works with HTTP 1 at the moment. Yes.
Yep. The next question from Arvin. Which one should be used and what are the difference between Azure Storage Queue versus Service Bus Queue to pass small messages? Which one is faster, more like from a performance perspective?
Yep.
Or in standard, like he's looking for standard, like in standard tier, which one is faster?
Yep.
GPv1 queue versus standard service bus queue.
Yep. So yeah, a couple of things, right? So depending upon what size of message it is, if you have anything below 64 KB, then obviously I would go for storage queue. But if you have something more than 64K, which is Service Bus gives you the ability to send messages around 256K minimum. So that's basically one of the assessment point that I would have. Again, how fast you want to process, right? How fast you want to send messages as well. So if you have a limitation, if you don't have a limitation and you want to go really fast, then maybe Service Bus is your option. And again, depending if you want to have multiple subscribers to your message. So if that is your use case, then you obviously then want to go for a more advanced thing like Service Bus Topic, where you can have your message broker allowing you that routing mechanism as well. So that's pretty much I would consider at a high level.
Looking at the next question, if we have a scenario like wanting to receive all receipts from our stores into Azure, it sounds like messaging services would be a good fit. Which services would you look towards for this, and what are the different considerations?
Sorry, Shri, could you repeat the first part of the question?
Yep. So there is a service, so they are looking for, what they want is like they have got a lot of receipts from the store, they want to process those. It sounds like a messaging service. What service can be used, and what are the different considerations people should be doing while making that decision? Yeah,
sure. So again, right, so depending upon your business use case over here, so if you have an expectation of fulfilling something at the back of that, it seems like it's just a receipt and you don't need to do any other fulfillment post that. So in that case, you would do something like a single consumer kind of thing as well. It could be could be an event grid. It's just a notification, right? So I would think it's more depending upon whether you need to consume that message in some form or shape and do some forward processing at the back of it, which is like a transaction-based process. If it's a transaction-based process, then I would definitely go for Service Bus. What it also allows you to do is basically, as I said, Service Bus gives you the ability to have sessions. So if it's a transaction-related processing, then I would probably do that at the back of Service Bus. Gives you the ability to create that virtual queue where you have all your session-related messages stored together. So depending upon the business use cases, what you need to do post that.
Yep. One last question. We have got two more in the queue, but before that, this is the last question from the published ones. Can the service, especially the Event Hub, be integrated with private VNet? Are they secure for an enterprise environment?
Yes, great question. So yeah, Event Hub, you could use private endpoint if you want to. I haven't personally configured that, but definitely that's now available. So using private endpoint, you are able to ensure that the traffic remains within your own network and there is no internet connectivity. Yep. So that's definitely possible.
Yeah. So with the private VNet, people are talking about it's most likely like you get a private IP actually for your instance, and that's what you use to connect.
Yes.
Cool. So is there an on-premise option for Service Bus instead of Azure Cloud?
Yeah, so Service Bus gives you an option of Service Bus Relay, which allows you to connect your cloud resources to your on-premises resources. So you could use Service Bus Relay to do that kind of connectivity between your on-prem resources to your cloud resources. Yes, Service Bus Relay is what you need to look into.
Is there any automatic way of moving messages from dead letter queue to main queue for processing, maybe after some time?
I haven't recently checked that, but that's a great feature request that I'm sure would have been there. I'm not sure about it. I've had my own function I've basically run and process the dead letter queue and push it back into my put it back on the queue. I'm not sure whether that's changed, whether we have some.
So you can use At this point, you can use either Azure Function or even Logic app as well to push it back into the main queue and read process. Yeah. But yes, once we have the feature available, yeah, that would be amazing.
Yeah, there's another feature which is the forwarding feature on Service Bus as well that you might be able to use as well. So you can forward a message from one topic to another. So it's nothing but a subqueue that it creates. Dead letter is a subqueue that gets created within your queue. So you might be able to forward that to another queue so that you can process it from there as well.
Yeah.
Yeah. It's got auto forwarding.
Yes, auto forwarding. Yes, that's called auto forwarding. Do we have any other question? Any other question? Okay, maybe from the audience, like obviously I can't see you guys. I can see the only amazing Atul. Maybe you guys can quickly ping us how many of you are using any of these integration services right now, and how many of you are planning. So either planning or you are using them. I'll just wait. I'll give it a minute, and also please give your feedback. Your feedback is very important for us. Like last week, we received some feedback from the GitHub session that you guys wanted more hands-on session, and now we like all these demos and everything. So we had this session filled with demos. Let us know how you feel about that as well. So please share your feedback. Okay, I have got one response from Himal saying he's already using the integration services. There is another one using it a lot of storage queue. Good. Notification hub, that's amazing. So yep, there are a lot of people using it. Service bus, awesome. So yes, there's someone planning. People who are planning, I will quickly post my email address. I'll publish my email address. So just to let you guys know, I'm pretty sure you guys have seen me in one of the sessions. I'm Shri, and I have got my all of Australia team with me. They are also in the call today. Our role as an app dev specialist in Microsoft is to help you guys through the implementation phase. Whenever you're making a decision, you're implementing something, we go through architecture and make sure you're doing the right things. So I will post my email address. Feel free to reach out to me, and we can have a discussion on how you can implement it. We can do some one-on-one sessions if required, and make sure you guys are on the right track. So I'll publish my email address.
Yeah, one more thing, Shri, I had one of my friend ask me a question before the session, right? He wanted me to know, what if I have my workload running using Apache Kafka at the moment? What can I do with Azure? And Event Hub is one service that pretty much integrates seamlessly with your Apache Kafka kind of code. You don't need to do any other changes. Pretty much just a configuration change, and you can seamlessly integrate your application code that's running elsewhere, sending messages to Apache Kafka using Apache, sending messages to Event Hub using Apache Kafka style messages. So just a configuration change. It provides you a endpoint where you can push messages, which is quite similar. The other thing that I didn't share was with Event Grid. We have two different schemas that we support, which is we have the Event Grid schema and we have the Cloud Native schema. So the Azure team is quite actively working with CNCF to ensure that they can use this Cloud Native format. So it basically allows you to integrate your applications with a lot more audience that are now working on this the Cloud Native schema as well. So that's quite interesting in that space.
That's a really good call-out, Atul. I know that's really consistent across the Microsoft Messaging Services landscape. So for example, on the message bus side as well, we do have integration and support for RabbitMQ queues. And since a couple of months ago, we now also support the Java messaging services. So definitely a much wider landscape that you can support on Azure now.
Yep. Yeah.
And also, I'll just add one more thing, which is very exciting about the BizTalk migration services also that is available. So that is another big add-on on the integration side. So there's BizTalk is going end of life, so people would love to migrate them. And we have got already services available, which is going to help you migrate from BizTalk. Before we leave, we have one more question. I just saw it. I'm just looking for the question ready to go. 1 second. Yes, 2 more questions actually. Can any of the message queues or non-code services pick data up from a UDP port and make this available for processes that can process this.
Sorry, could you repeat that, Shri, again?
Yeah. Can any of the message queues or non-code services pick data up from a UDP port and make this available for processes that can process it?
Right. Okay. I'm not sure on that one. I'll have to check and let you know.
Yep.
So feel free to. I think I shared that contact detail before. Feel free to ping me on my LinkedIn. I'll surely try and respond to it. You can send that question to me on my email as well, and I'll be more than happy to respond to you back. But I'm not sure at this stage. Sorry.
Yep. So we have. Yep. Imran has answered the next question, which is good. I think we are all good today. Awesome. Thank you, Atul. Thank you for an amazing session. We all loved it. And everyone, please, again, provide your feedback. We really look forward to your feedback, and we look at it before going through the next session. So before every planning and everything, we go through a feedback. So please send us your feedback and also reach out to us if you have any questions. That's it for today, and thank you all.
Thank you very much. Thanks, Shri.
Thanks.